Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on rates of change. If you need any extra help on rates of change, so whether that's instantaneous or average, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video numbers 390A and 390B, there's dedicated video tutorials there that'll help you with rates of change. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says, a family are filling a large paddling pool and the graph shows the volume in litres of the water in the paddling pool as it is being filled. So we've got this graph, and as you can see it's a curve, and we've got, going up the vertical axis, the volume of the water in the paddling pool. So it starts at 0, so it's empty to begin with. And then going across horizontally we've got the time, so we've got the time from 0 to 80 seconds. And then if we go on down, part A says calculate an estimate for the gradient of the graph when the time is equal to 50 minutes. So we want to find an estimate for the gradient of the graph when the time is equal to 50 minutes. So 50 minutes is here, so that's the point there, and we want to find our estimate for the gradient of the graph at that particular point there. Now, one thing I want to mention, and I'm going to mention this probably quite a lot in this video, is whenever we draw our tangents, and we're going to be drawing these by hand, and on the GCSE Maths exam paper you're going to be drawing these tangents by hand, unless it's already drawn for you, or you know the exact coordinates of the points. But if you are drawing a tangent to a curve like this, the tangent may vary slightly. Now, the examiner knows that, and they appreciate that, and they know that that's okay, and whenever you draw your tangent, you might get a slightly different gradient than your friend or your teacher, but they'll have a particular range of values that you can go in between. They'll know a tangent like that would be wrong, so they'll know that gradient is too steep. But if you draw a gradient to this and it's between certain values, then that's okay. Okay, so let's draw a tangent to the curve. Okay, so I've just drawn the tangent to the curve at the point whenever time is equal to 50. So there's the point whenever time is equal to 50, and that's the tangent to the curve at that particular point. So I've got my ruler and tried to draw it in exactly the same direction as where the curve is going at that particular time, whenever time is equal to 50. And what we would now do is we'd find 2 points that are on that particular tangent, and we'll find the gradient between those 2 points, the gradient of the line joining those points. So what I'm going to do is I'm going to choose the points that I've chosen on the mark scheme. So I've tried to draw my tangent the same as what I've drawn on my mark scheme on Corbettmaths, so I've tried to do that the best I can. Okay, so the first point I'm going to choose is this point here, which is the point 50, 560, and it's 50, 560 because it's 50 across. In terms of going up vertically, each one of the little boxes, well, there's 5 little lines until you get to 200, so each one's going to be worth 40, and it's 1 below 600, so that's going to be 560. So you choose 2 good points on this tangent, and to me that was quite a good point. Okay, another point that I've chosen is this point here, and this point is the point with coordinates 40, and then it's 1 box below 400, so that's going to be, each box is worth 40, so 360. So that's that point there, 40, 360. So that's fantastic. We've now chosen 2 points on that tangent, and you can choose any 2 points, but I tend to choose what I call nice points, so points whenever that tangent passes through clear points. So here it was definitely there, that one was definitely 40 across and 360 up. Okay, so we've now got those 2 points. Now the question asks us to work out the gradient of the tangent, so the gradient of the graph whenever time is equal to 50. So you want to work out the gradient of that line. So to work out the gradient of a line, well, I like to turn it into a little right angle triangle like so, and I like to do rise divided by run, because the gradient m is equal to the rise divided by the run. So in terms of the rise, the graph rises by, well, it goes from a height of 360 to 560, so it rises by 200, so the rise is 200. And the run is how much we're going across, so it goes from 40 across to 50 across, so the run is 10, and we're going to do 200 divided by 10, and that's equal to 20. So that means the gradient of that graph is equal to 20. Now, I just want to point out that some people use a different formula for working out the gradient of a line, and that's fine as well. So they use m is equal to y2 minus y1 over x2 minus x1. So they learn that formula to work out the gradient of the line. And in terms of the points, the first point would be x1, y1. The second point would be x2, y2. And then you substitute those values in. So you'd end up with 560 minus 360 on the numerator, which is 200. And on the denominator, you'd end up with 50 minus 40, which is 10. And again, you'd end up with the answer 20. And that's it. So that's our first part. So our estimate for the gradient of the graph whenever the time was equal to 50 minutes is equal to 20. And just to mention, it is an estimate. So if you perhaps got 19.5 or 20.5, perhaps that might have been allowed. It depends obviously on the range the mark scheme gives. And then if we have a look at part B says describe fully what the gradient in part A represents. So what does this 20 represent? So if we have a look here, the graph shows us the volume in litres of water in the paddling pool as it is being filled. So we've got the volume of the water in the paddling pool going up the vertical axis, and we've got time going across the horizontal axis. So the gradient of this would be the rate of change of the volume. So it's how the volume is changing. So this 20 represents the rate of change of the volume. So in other words, the volume's increasing by 20 litres each minute at that particular moment. So whenever time's equal to 50 at this particular moment here, the rate of increase of the volume is 20 litres per minute. And that's it. So that's what it represents, 20 litres per minute is the rate of change of the volume. So let's explain that. And that's it. I've just explained that it's the rate of increase of volume of water in the pool at 50 minutes. It's the rate of increase. And it's 20 litres per minute. So at 50 minutes, the rate of increase of the volume is 20 litres each minute. And if we go up, if we want to find those units, we just have a look and consider what we've done. We've done the rise divided by the run. We took the rise, which was in litres, and we divided that by the run, which is in minutes, so to be litres per minute in terms of the units. And that's it. Okay, let's have a look at our next question. So question number 2 says a rocket is fired upwards as part of a science experiment, and the graph shows the height of the rocket above the ground. So we've got height on the vertical axis, and going across we've got time in seconds. So at 0, it's got a height of 0, so that's when it's being launched. And as you can see, the height of the rocket above the ground increases as the time goes up. So that's the height of the rocket at any particular time. And then if we go down, we've been asked to work out the average speed between 1 and 4 seconds. So what we want to do is we want to find the average rate of change. So I'm going to just change colour ink here to blue, and I'm going to mark on the points at 1 and 4 because it says average speed between 1 and 4 seconds. So rather than finding the gradient of a tangent at a particular point, which is the instantaneous rate of change, like in our last question, this time we've been asked to find the average speed, so we want to find the average rate of change between 1 and 4 seconds. We're going to join up those points with a chord, and then we're going to work out the gradient of the chord, and then that'll tell us the average rate of change between 1 and 4, and in terms of this question, that'll be the average speed, because the average rate of change of distance is the speed. Okay, so I've joined up those points with a chord, and I'm just going to write down the coordinates of those points. So this point is the point 1, so 1 across, and in terms of the height, it's halfway between 8 and 16, so that's going to be 12, because we're going to go 4 up and another 4 up, so that'll be 12. And then we've got this point here, which is 4 across, and in terms of the height, well, it's halfway between, it's halfway between this line and this line. This is 24, so we're going up in 4s, each of the big boxes is 4, so that's going to be 28, and this is in the middle of 28 and 32, so that'll be 30. Or another way to consider it is that if we go from 0 to 8, there's 10 little boxes, and 8 divided by 10 is 0.8. So in the middle here is 28, so 28.8, 29.6, and then we're going halfway, which is 0.4, so that'll be 30. So that's fantastic. We've now got the coordinates of the 2 points. We want to work out the average rate of change, so we want to work out the gradient of that chord. So let's do that. So to work out the gradient, we're going to do rise divided by run. So we're going to do the gradient is equal to the rise divided by the run. In terms of the rise, well, let's turn this into a little right angle triangle. So I'm just going to go across and then I'm going to go up and turn that into a little right angle triangle there. In terms of the rise, it's going from a height of 12 up to a height of 30. So that's a rise of 18. And then we're going to divide that by the run. We're going from 1 across to 4 across, so that's going to run a 3. We're going 3 across. So the rise is 18 and the run is 3, and 18 divided by 3 is equal to 6. So that means that the average rate of change between 1 and 4 is equal to 6. Now, in terms of this question, we're finding the speed. So if we have a look here, we've got meters going up vertically. So the rise was in meters. The run was in seconds, so we're dividing meters by seconds, so that's going to be meters per second. So the answer will be 6 meters per second, and that's it. Okay, let's have a look at our next question, question number 3. So question number 3, we've been told the water's been emptied out of a bath, and the graph shows the depth of water for the first 6 seconds. So we've got the depth of water, so at the beginning it's got a depth of 16 centimeters, and by the time it gets to 6 seconds, the depth is quite low there. It's not empty, but it's very low, it's just above 0. And then if we go on down, we're told to use the graph to work out an estimate for the rate of decrease of depth at 1 second. So we want to use the graph to work out an estimate for the rate of decrease of depth at 1 second. So because it says at 1 second, we're working out the instantaneous rate of change. So we want to work out the gradient of the tangent at 1 second. So let's draw a tangent at 1 second. Okay, so I've gone to the curve and looked at whenever time is equal to 1 second, so that's there, and I've drawn a tangent to the curve at that particular point. Now remember that our tangents may vary slightly, so whenever I'm working out the gradient here of this tangent, it may vary slightly to yours, but again, it's just the technique that we're looking at. So what I'm now going to do is I'm going to choose 2 good points on that tangent. So I'm going to choose this one here, because this point here it's just below 12, so it's 0.5 across, so that point there is 0.5 across, and in terms of its height, it's 1 below 12. And here, if we go from 0 to 4, it takes 10 little boxes, and 4 divided by 10 is equal to 0.4. So each of the little boxes is 0.4. So there's one box below 12, so it's going to be 11.6. So that's the coordinates of that point. Okay, now let's find another good point on the line. Now, I'm struggling to find a good point on the line, so I'm going to choose this one here. Okay, and I'm choosing this one here because that's what I've done on the Mark Simon Corbettmaths. Now, you can choose any particular point here. So this particular point here, I've got it that it's above halfway between that line and that line. So I'm going to say it's about 3/4 of the way through that box. So in the middle, well, each of the little boxes is worth 0.4. So the top of the box would be 4.4. In the middle would be 4.2. I'm going to say the height there is equal to 4.3. So that particular point, the coordinates would be 2, 4.3. Okay, now you can choose any particular point, and again, it is an estimate, so just try and be as accurate as you can here. So I've got that's equal to 2, 4.3. Okay, now we want to find the gradient of the tangent, because that'll tell us the rate of change at that particular point. So what we're going to do is we're going to do the gradient, m is equal to the rise divided by the run. So let's do a little right angle triangle. So we go across here and then down. So that's our little right angle triangle, and let's label the run and the rise. So in terms of the run, we're going from 0.5 across to 2, so that's going to be 1.5. So the run is equal to 1.5, and the rise, we're going from a height of 11.6 down to 4.3, so that means that the rise would be negative, we're going down, and it's going down by 7.3, so 7.3. So we've got the run, which is 1.5, and we've got the rise, which is minus 7.3. So we're going to do the gradient, which is the rise divided by the run. So it's going to be minus 7.3 divided by 1.5. And when we do it on our calculator, we get an answer of, we get that's equal to minus 4.86 recurring. So 666 and so on. I'm just going to put a little dot above it. And that's it. So that would be the gradient of that line. So what that means is, in terms of the context of this question, because remember this is the depth of water in a bath being emptied out, and at 1 second the rate of decrease is 4.86 recurring centimeters. So at that particular time, the rate at which the water is decreasing, the depth of the water in the bath is decreasing at a rate of 4.6 recurring centimeters at every second. Now if we go down, the question didn't ask us for the rate of change, it asked us for the rate of decrease. So it already knew that it was decreasing, and it wants to know us what rate is the depth of the water decreasing whenever the time's equal to 1 second. So it's decreasing by 4.6 recurring centimeters per second. That's the rate of decrease of the depth of the water in the bath, and that's it. So the answer would be 4.86 recurring. And that's it. So because the question says rate of decrease, it already knew that the gradient was a negative, so we've just made it a positive to tell us the rate of decrease. And that's it. Okay, let's have a look at our next question, question number 4. So question number 4 says the graph shows the distance travelled by a runner. So this is a distance time graph, so we've got distance going up vertically and time going across horizontally. And remember that the gradient of a distance time graph is the speed. So if we find the rate of change of distance, that's the speed. And if we go down, we're told part A, work out an estimate for the speed of the runner at 10 seconds. So we want to find an estimate of the speed of the runner at 10 seconds. So we want to find an estimate of the speed. So that's the estimate of the rate of change of this graph. So we want to find the gradient of the tangent at this particular point. So let's draw a tangent at times equal to 10 seconds. Okay, so I've drawn my tangent to the curve at times equal to 10 seconds. Obviously your tangent may be slightly different. So that's the tangent. Now we want to find the gradient of this tangent. So let's choose 2 good points on the tangent. Okay, so one good point that I can see straight away is 25, 100. So 25 across and 100 up. That's definitely a good point to choose. And another good point that I can see here is this one here. It's exactly 1 squared below 50. So this point would be the point with coordinates 12.5 across, because it's halfway between 10 and 15. And in terms of the height, it's 1 box below 50, so it's going to be 45. So they're the coordinates of that point there and that point there. And they're the 2 good points that I've chosen on that tangent. Now what we want to do is we want to work out the gradient of that line. So we're going to do rise divided by run. So the gradient would be equal to the rise divided by the run. So let's do a little right angle triangle. So let's go across and then go up. In terms of the run, we're going from 12.5 across to 25. So that's another 12.5. So 12.5 is the run. And in terms of the rise, we're going from a height of 45 up to 100. So the rise would be 55. And again, just to mention that you may have chosen different points on your tangent. So obviously here you may have different values for your run and your rise, but hopefully whenever you do the rise divided by the run, your answer will be pretty close to what I get. So we're going to do the rise, which is 55, divided by the run, which is 12.5. And when we do 55 divided by 12.5, let's see what we get. So 55 divided by 12.5 is equal to 4.4. So that is 4.4. In terms of the units, we're doing meters divided by seconds. That's meters per second. So that means the speed of the runner at 10 seconds is 4.4 meters per second. And that's it. And then part B. Part B, we've been asked to work out the average speed of the runner between 19 and 24 seconds. So we want to work out the average speed of the runner between 19 and 24 seconds. So because it says the average speed of the runner, and remember that the speed is the rate of change for a distance time graph, we want to find the average rate of change. So we're going to plot the point at 19 across and whatever the height is on the curve. We're going to go to the curve and we're going to go 24 across and plot that point at 24 and whatever the height is. And we'll join up those 2 points to make a chord, and we'll work out the gradient of that chord, and that'll be the average speed of the runner between 19 and 24 seconds. So let's do that. So 19 seconds, well, if we go 19 across, so we've got from 0 to 5 is 10 little boxes, so each box is worth 0.5, so that would be 17 and a half, 18, 18 and a half, 19, so 2 little boxes before 20. And if we go up, that's the point there. That's quite a nice point actually. So it's 19 across, and in terms of the height is 2 boxes below 100, so it's going to be 90. Okay, so that's 1990. That's a good year. 1990. So that's the first one, 1990. Okay, then if we go across to the next one, well, we wanted the average speed between 19 and 24 seconds. So 24 seconds, that's going to be 2 boxes before 25. And if we go up here, 2 boxes before 25, that's another good point. So that's the point with coordinates 24. And then in terms of the height, that'll be 140, because each of the little boxes were 5, so it's going to be 2 boxes below 150, so that's 140. So we want to find the average speed between these two times. So we want to join up those points. So we're going to join up that point to that point, and we're going to work out the gradient of that chord. And the gradient of the chord will be the average rate of change between those particular points. Okay, so let's write the formula down. The gradient is equal to the rise divided by the run, or you could do y2 minus y1 over x2 minus x1, and you'd get 140 minus 90, which is 50. It's divided by 24 minus 19, which is 5, and that'll give you answer there is 10. Alternatively, we could do the rise divided by the run, so let's do a little right angle triangle. So we're going to cross and then we're going up there. In terms of the run, we're going from 19 across to 24, so the run is 5, so the run is 5. The rise, we're going from a height of 90 up to 140, so the rise would be 50. And when we do 50 divided by 5, that's equal to 10. And again, we're doing meters divided by seconds, that's going to be meters per second. And that's it. So the average speed of the runner between 19 seconds and 24 seconds is 10 meters per second. And that's it. Okay, let's look at our next question. Okay, question number 5. Question number 5, we've been given part of the graph of y equals x squared minus 2x minus 3. So we've got this quadratic, this U-shaped parabola. And the question says, P is the point on the graph of y equals x squared minus 2x minus 3, where the x coordinate is 2. And we've been asked to calculate an estimate of the gradient of the graph at the point P. So let's find out where the point P is. So we know the point P has got an x coordinate of 2. Now, to find where the point P is, there's a couple of approaches we could use. One is to substitute 2 into the equation, and you get 2 squared is 4. Take away 2 times 2, which is 4, so 4 take away 4 is 0. Take away 3 is negative 3, so it's the point 2, negative 3. Alternatively, because you know it's on the curve, you could just go to 2 across, and then go to where it is on the graph, which would be there, which is the point 2, negative 3. So you just go 2 across and go to the graph, and it's there, 2, negative 3. Okay, so we want to find an estimate for the gradient of the graph at this particular point. So let's draw a tangent at the point 2, negative 3, the point P. So let's do that. Okay, so I've just drawn the tangent to the curve at the point P. So that's my tangent there. Again, remember yours may differ slightly. And now I'm going to choose 2 good points on that tangent. And so the points I'm going to choose are this point here, so the point 4 across. And in terms of the height, well, we're going from 0 up to 2 in 10 little boxes, so each one's worth 0.2, so 0.2, 0.4, 0.6, 0.8. So that'll be the first point, the point with coordinates 4, 0.8. And then in terms of another point, I'm going to choose this point here, the point there, which is 1 across. And in terms of the height, again, each one of the little boxes going up vertically is 0.2. So here's minus 5, so it's going to be minus 5.2. So we've got those 2 points. Now we want to work out the gradient of the line that passes through those points. So let's do the gradient, the m is equal to the rise divided by the run. In terms of the rise, well, let's do a little right angle triangle. So in terms of the run, we're going from 1 to 4, so the run is 3, so it's going to be over 3. In terms of the rise, we're going from minus 5.2 up to 0.8, so that'll be a rise of 6 actually. So we're going to do 6 divided by 3, and 6 divided by 3 is equal to 2. So our estimate for the gradient of that curve at that particular point P is equal to 2, and that's it. Okay, let's have a look at our next question, question number 6. So question number 6 says, below is a velocity time graph of a car journey. So we've got the velocity going up vertically in meters per second, and going across horizontally we've got the time. And we've been asked to work out the average acceleration over the first 20 seconds of the journey and to state units of this acceleration. So we want to find the average acceleration over the first 20 seconds. That's going to be average acceleration, so that's between 0 and 20 seconds. And acceleration is the rate of change of velocity, so that's going to be the rate of change of this graph. So we want to find the average rate of change between 0 and 20 seconds. So 0 is here, the point 0, 0. I'm just going to label that 0. 0 and 20 seconds, the point would be up there, which is 20 and okay, so it's a box and a half. So if you go here, we've got the vertical scale here, so from 0 to 2, and that's 2 in 5 little boxes, and 2 divided by 5 is 0.4, so it'll be 0.4 and then 0.6, so that's going to be 14.6 being the height. Now again, with that one there, because it wasn't exactly through one of the points, you could have actually said perhaps 14.5 or 14.7 or something like that. So there may be a slight difference in terms of our answers, but in terms of the technique, this is what we would do. So we want to find the average acceleration. So now let's join up those points, and we want to find the gradient of this line. So to find the gradient of this line, we're going to do rise over run. So m, the gradient, is equal to the rise divided by the run. The rise, well, it's going from a height of 0 up to height of 14.6. So the rise would be 14.6, so 14.6. And the run, we're going from 0 to 20, so the run would be 20. So if we do 14.6 divided by 20, that'll be the gradient of this line. So if we do 14.6 divided by 20, that's equal to 0.73. So that's equal to 0.73. So the gradient of this chord is 0.73. So that means that our answer would be 0.73. Now we need to consider our units. We're doing the rise divided by the run. So we're going to, if we look at the axes here, we've got meters per second. And we're dividing that by seconds. So that's going to be meters per second, or the way we'd write that is meters per second squared. Okay, so the rate of acceleration will be meters per second squared. And that's it. That's our answer, 0.73 meters per second squared. Okay, and then if we have a look at part B, part B says use the graph to calculate an estimate for the deceleration of the car whenever time is equal to 35 seconds. We've been asked to state the units for the deceleration. So first of all, we know the acceleration is meters per second squared, so the deceleration is also going to be meters per second squared. I'm just writing that there to begin with. Okay, time is equal to 35 seconds. So we want to find the estimate for the deceleration of the car whenever time is equal to 35. So we want to find the instantaneous rate of change at this particular point. So let's draw a tangent. Okay, so in terms of 2 good points, I think this is a good point here. So that's the point 30, 12, so 30, 12. And then I think this is a good point here, the point 48. So those 2 points are really good points on the line, and we've got this one and this one. So if we work out the gradient between them, so if we do the rise divided by run, so m is the rise. So we're going from a height of 12 down to a height of 8, so that'll be minus 4 is the rise, going down 4, minus 4, divided by the run. Well, the run's going from 30 to 40, so the run is 10. So we're going to do minus 4 divided by 10, which is minus 0.4. So that means the gradient of this line is minus 0.4. So that means the rate of acceleration would be minus 0.4 meters per second squared. But because the question says deceleration, it already knows it's slowing down. So that means it's going to be just 0.4 meters per second squared. We don't need to write the minus sign when we say deceleration. And that's it. Okay, let's look at our next question. Question number 7 says, some students carry out an experiment and they record the speed of a toy car during 12 seconds. So here we've got the speed of the toy car. It starts at rest and then obviously accelerates. It goes up to a high speed up here somewhere and then sort of comes down and up and down again and so on. Okay, so we've got the speed of this toy car over 12 seconds. And if we go on down, we've been asked to calculate the acceleration of the toy car at 3 seconds. So the acceleration, if you've got a speed time graph, the acceleration is the gradient at a particular point. So if we want to find the acceleration of the toy car at 3 seconds, we're going to draw a tangent to the curve at 3 seconds and then find the gradient of that tangent. So let's draw the tangent to begin with. Okay, so that's the tangent that I've drawn to the curve at 3 seconds. So that straight line there is the tangent. Now we want to find the gradient of that tangent, and that gradient will be our estimation to the acceleration of the toy car. So let's find 2 good points on that tangent. So I think that's a good point there, the point 2, 0.5, because it's 2 across and 0.5 up, halfway between 0 and 1. And then another good point would be this one here, the point 6, so it's 6 across, and then it goes up to 2.7, so 2.7. So I've chosen those 2 points, and remember that your points may be slightly different than mine, but obviously, hopefully, whenever we work out the gradients, it'll be pretty close to each other's, okay? Okay, so the gradient of the tangent will be equal to the rise divided by the run, so rise over run. So now let's turn it into a right angle triangle, so let's go across, and then up. Okay, so that's our right angle triangle. The run, we're going from 2 across to 6 across, so that's going to be 4. The run's 4. And in terms of the rise, we're going from a height of 0.5 up to 2.7. So the rise would be 2.2. So we've got the rise and the run. Now the gradient would be the rise, which is 2.2, divided by the run, which is 4. And when we do 2.2 divided by 4, the answer is 0.55. So that means the gradient of this tangent is 0.55. And what that means is the acceleration of this toy car at 3 seconds would be 0.55 meters per second squared. And that's it. So the acceleration of the toy car at 3 seconds would be 0.55 meters per second squared. Okay, next, part B. Part B says write down the time when the toy car was not accelerating. So whenever it's not accelerating will be whenever the gradient is equal to 0. So in other words, we want to find, if we go back up to this curve, when is the curve flat? So when would the tangent have a gradient of 0? So let's go up. And then what I'll do is I'll take my ruler and I would find where on the curve I think that the gradient is equal to 0. In other words, when is it flat? And I've got here, whenever the time is equal to 8 seconds. So that's one possible answer there, 8 seconds. So whenever the time is equal to 8 seconds, the graph is flat, so it means there's no acceleration. The tangent has a gradient of 0. So that would be one answer, whenever time's equal to 8. So I'm going to write that down, time's equal to 8 seconds. Okay, so that's one possible answer. There are other possible answers here. If you have a look here, I think that the gradient is flat around about there somewhere. So that would be about 10.9, something like that. In 10.8, 10.9. Also here, I would say the gradient's flat there as well, which is about 10.3. But there's a few different possible answers. But I've gone for this one here, whenever the time was equal to 8 seconds, because the question said just write down a time whenever the toy car was not accelerating. So there's a few different choices there. Okay, let's look at our next question, question number 8. So question number 8, we've got this graph and it shows the distance travelled by a train over 36 seconds. So as you can see, we've got the time going from 0 to 36, and we've got the distance travelled going up vertically, and the distance travelled starts at 0 and goes up to a greatest distance of 300 metres. And then if we go on down, we've been asked to work out the average speed of the train between 6 and 18 seconds. So if you've got a distance time graph, if you want to work out the speed, you work out the gradient of that graph, and it's the average speed between 6 and 18 seconds. So we want to find the points on the curve at 6 seconds and 18 seconds. So let's find those points at 6 seconds and 18 seconds. So 6 seconds would be there, and 18 seconds would be here. So there's the 2 points, and we want to find the average speed between them. So we want to find the gradient of the chord that joins up those 2 points. So we want to find the gradient of that chord. And the gradient of that chord will be the average speed between 6 and 18 seconds. Okay, so to find the gradient of that chord, the first thing I'm going to do is I'm going to label the coordinates of the points. Okay, so if we go to this point down here, it's 6 across, so it's definitely 6 across. In terms of the height, it's just above the line. So in terms of the line, there's 10 little lines, and the scale goes from 0 to 50. So if we do 50 divided by 10, that's equal to 5. That's just above one of those, so I'm going to say that's 6. Okay, so that's in terms of what I think the height is. You may have chosen 5 or 7 or something like that, but I've gone for 6 there. In terms of this point here, its coordinates are 18. And then in terms of the height, it's the fourth little box there. So we're going up in 5, so 105. 110, 115, 120, so that's 120. So we've got the coordinates of the 2 points. Now to find the gradient of that chord, we're going to do the rise divided by the run. So let's just turn it into a little right angle triangle. So a little right angle triangle, like so. And we're going to do the gradient, m is equal to the rise divided by the run. So in terms of the rise, we're going from a height of 6 up to 120, so that's a rise of 114. And in terms of the run, we're going from 6 across to 18 across, so the run would be 12. So we're going to do 114 divided by 12. And when we do 114 divided by 12, that gives us our answer. And that's equal to 9.5. So the gradient of that chord is 9.5. So that means that the average speed would be 9.5 meters per second. So let's write that down, 9.5 meters per second. And then if we go on down, part B says estimate the highest speed reached by the train on the journey, and to give our answer in kilometers per hour. So we want to find an estimate of the highest speed. So in terms of this graph, remember the speed is the gradient. So in terms of this, if we want to find the highest speed, we want to find the highest gradient. So I would take my ruler and I'd go to the graph and I'd think, where is the steepest gradient? So I'd move my ruler around until I found the steepest tangent to the graph. And I would say it's about there somewhere. And that's where I think the steepest gradient would be. So that would be the highest speed reached by the train. So if you were actually go further to the right, so choose a point over here somewhere, what you'd find is the tangent wouldn't be as steep as this one. If you did choose a point down here, the gradient wouldn't be as steep. So I think it's going to be around here somewhere. Okay, so now let's choose two good points on that tangent. So I'm going to choose this point here. This point here is, well, it's got a height of 150. And in terms of the horizontal position, well, it's exactly halfway between that line and that line. So if that's 18 and that's 24, this would be 21, and then that'll be in the midpoint, so that'll be 19.5. So 19.5 and 150. So that's the coordinates of that point. And then in terms of another good point, I would say this point here. Okay, because this point here, it's got a horizontal position of 24, it's 24 across. In terms of the height, it's halfway between here and here. Well, this is 200, this is 250, so that's 225. So it's in the midpoint of 225 and 250, which would be 237.5. Okay, so we've now got our 2 points, this point 19.5, 150, and this point 24, 237.5. Now what I'm going to do is I'm going to turn it into a little right angle triangle, and I'm going to do rise over run. So the gradient is equal to the rise, which should be, let's work out the rise, we're going from 150 up to 237.5, so that'll be 87.5. And the run would be, well, we're going from 19.5 to 24, so that would be 4.5. So we're going to do 87.5, the rise, divided by the run, which is 4.5. And when we work that out, we get an answer of 19.4 recurring, and that's in meters per second. So that's our estimate for the greatest speed reached by the train. Now the question didn't actually want it in meters per second, it said give your answer in kilometers per hour, so that's 19.4 recurring meters per second. Okay, so I'm going to times this by 60. So if I times this by 60, if I take the 19.4 recurring and times it by 60, I get that's equal to 1166.6 recurring meters per minute. Then I'm going to times by 60 again, and if I times by 60, I get that's equal to 70,000 meters per hour. Now I don't want it in meters per hour, I want it in kilometers per hour, so I'm going to divide by 1,000, so that'll be 70, so 70 kilometers per hour. So that's our estimate for the greatest speed to reach by the train on that journey, and that's it. Okay, let's look at our next question. So question number 9 says, Jack is filling a container with water, and the graph shows the depth of water in centimetres t seconds after the start of filling the container. So we've got this graph, and we've got time going across horizontally from 0 across to 27.5, and we've got the depth going from 0 up to 5 in terms of centimetres in terms of the water in the container. And then if we go on down, part A says calculate an estimate for the gradient of the graph whenever t is equal to 15 seconds. So we want to find an estimate for the gradient of this curve at times equal to 15. So times equal to 15 is here, so let's draw a tangent to the curve at that particular point. Okay, so that's the tangent I've drawn to the curve. Okay, so now to find the gradient of that tangent, we're going to choose two good points on that tangent. So I'm going to choose this point here, the point 0, and then it's the second box up above that midpoint there. So it's going to be, that's 1, 1.6, 1.7, so 1.7, so 0, 1.7. And then in terms of another good point, I think this would be a good point here. The point 25 across, so it's 25 across, and then it's got a height of 4.5. So that's fantastic. We've now got two good points on that tangent. Let's find the gradient between them. So m, the gradient would be equal to the rise divided by the run. So we're going to take the rise. Well, let's turn this into a little right angle triangle. So let's go across. In terms of the run, that's going to be 25. And in terms of the rise, we're going to do 4.5, take away 1.7. That's going to be equal to 2.8. So we've got the rise and the run. Now we just need to do 2.8 divided by 25, and then that'll be our gradient of our tangent. So let's work that out. So 2.8 divided by 25 is 0.112. So that means the gradient of the graph at times equal to 15 seconds would be 0.112. And then part B says describe fully what the answer to A represents. Well, let's go up. Well, we want to find out what the gradient to this curve represents. So we've got the depth going up vertically, we've got the time going across horizontally. In terms of the gradient of that curve, that's going to be the rate of change of the depth. So it's going to be the rate at which the depth of water in the container is increasing. So let's write that down. So I've written down is the rate at which the depth of water in the container is increasing, which would be 0.112 centimetres per second. So whenever the time is equal to 15 seconds, the rate at which the depth is increasing is 0.112 centimetres every single second. And that's it. And in terms of those units, I just looked at centimetres and seconds, so it's centimetres per second. Okay, and then part C. Part C says explain why A is only an estimate. Well, we drew our tangent by hand. We didn't know exactly how the tangent would be. My tangent may be slightly different than your tangent, so let's write that down. And that's it. I've just written down, as it's a hand-drawn tangent, it may not be precise. And that's it. Okay, let's look at our next question, question number 10. So question number 10 says a speed time graph shows information about a tram journey between two stops. So we've got this speed time graph. We've got speed going up vertically and we've got time going across horizontally. And if we go on down, part A says work out an estimate for the gradient of the graph at times equal to 40. So we want to find an estimate of the gradient of this graph whenever t is equal to 40. So if we go across the 40 seconds and up, that brings us to here. So that's the point there. And we want to draw a tangent at that point and then work out the gradient of that tangent. So let's do that. Okay, so we've drawn the tangent to the curve whenever time is equal to 40. So there's the point that's on the curve whenever time is equal to 40, and we've drawn the tangent at that particular point. Now what we want to do is we want to work out the gradient of that tangent. So let's find 2 points that are on that line. So I'm going to choose this point here, the point 60, 12, so 60 across and 12 up. And then actually I'm going to choose the point here whenever time is equal to 40, the point that we drew the tangent at. And that is 40 across, and in terms of the height, it's 3 little boxes above. So here we've got 8, and 10, so that's going to be 9. So we're going up a 0.2, so that'll be 9.6. Okay, so we want to find the gradient of this tangent, so I'm going to make a little right angle triangle, like so. And in terms of the run and the rise, so the gradient is equal to the rise divided by the run. The run, we're going from 40 to 60, so that's going to be 20. And the rise, we're going from 9.6 up to 12, so it's going to be 2.4, 2.4. So to find the gradient, we're going to do 2.4, the rise, divided by the run, which is 20. And whenever we divide 2.4 by 20, we get that's equal to 0.12. So that means the gradient of the tangent to that curve whenever time is equal to 40 is equal to 0.12. And then part B says describe fully what the answer to A represents. Well, it's a speed time graph, and we've found the rate of change whenever time is equal to 40, that instantaneous rate of change. So the rate of change of speed is acceleration. And if you also think of the units, it's meters per second divided by seconds, so it's going to be meters per second per second. So that's going to be meters per second squared, which is the units for acceleration. So it represents acceleration whenever time is equal to 40. So let's write that down. And that's it. I've just written down that the answer to A represents the acceleration of the tram at times equal to 40. And the A, the acceleration, is 0.12 meters per second squared. And then if we go to part C says describe what the area under the graph represents. So sometimes rates of change questions are also linked into area under the graph questions. And if you go to Corbettmaths and watch the video tutorial area under a graph, that'll explain that in a bit more detail. But if you've got a speed time graph and you find the area under that graph, that represents the distance traveled. And if we go back up, the graph represented the journey between two stops. So actually in this case, the area under that graph would represent the distance between the two tram stops. So let's write that down. And that's it. I've written down both options there. So it represents either the distance travelled by the tram or the distance between the two stops. Okay, and let's look at our last question, question number 11. So question number 11, we've been given the graph of y equals f of x. So that's a function of x. And let's have a look at the graph. It actually looks like a cubic graph because it comes up, reaches a maximum turning point, comes down, reaches a minimum turning point, and then goes back up again. So this looks like the graph of a cubic. And then if we go on down, part A says write down the coordinates of the two turning points off the graph. So let's write down the coordinates of the maximum point and the minimum point. So here's the maximum point here. So let's write down the coordinates of that point. So in terms of the maximum point, I think that's the point there. And then let's write down the coordinates of that point. So here we've got -1, and then we've got -1.5. So -1.1, 1.2, -1.3, -1.4. It's in the middle there, so it'll be -1.35. In terms of the height, here's 0.5, 0.6, 0.7, and it's just above 0.7. So I've gone for 0.72, something like that. So that's what I've written down for the coordinates of the maximum points. So that would be -1.35. And 0.72. And then in terms of the minimum point would be here. And there's 0.5, so that'll be 0.4, so that'll be 0.45, so 0.45 across. So 0.45 across. And in terms of the height, -2, -2.5. It's not -2.6, it's going to be -2.55. I've gone for there, so it's -2.55. And that's it. Okay, and then if we go on down, part B says estimate the roots of f of x equals 0. So notice this is the graph of y equals f of x. And here we've got f of x equals 0. So in other words, the y has changed to 0. So that's when the height is 0. So if you want to find the estimates of the roots of f of x equals 0, we just need to find where the graph crosses the x-axis. So we want to find this value of x here, this value of x here, and this value of x here. And they will be the three roots. So let's find each of those values. So this one here would be, well, 1.1, 1.2, 1.3. So that's, I think, 1.25. So let's write that down, 1.25. 1.25, that's one of the roots. Another one would be, well, this one here would be, well, negative 0.8. So I'm going to say minus 0.8. And then the other place where it crosses the x-axis would be here. So we've got negative 2, negative 1.9, negative 1.8. It's actually just before that. So I'm going to say about negative 1.82. So let's write that down. So negative 1.82. And there are three solutions that x equals. So x equals negative 1.82, negative 0.8, or 1.25. And that's it. That's our estimate for the three roots of that equation. Okay, and then if we carry on, part C. Part C says use the graph to find f of 1.5. So notice it was y equals f of x. And here the x is changed to 1.5. So in other words, it's asking us if we have a value of x of 1.5, what value would we get for y? So let's have a look at that. So we go to 1.5, so x is 1.5, which is here, and then we go on up, well, we get to here, which is 2. So that means that the value of f of x would be 2. So let's write that down. The answer would be 2. And then if we carry on, we're then told that P is a point on the graph of f of x where x equals negative 2. And then we've been asked to calculate an estimate for the gradient of the graph at the point P. Okay, so we want to find where x is equal to negative 2. So let's go back to the graph, and x is equal to negative 2, and now here's negative 2 on the x-axis, and if we go down, that's going to be this point. That's going to be this point here. And then we want to draw the tangent to the graph there. Because if we can draw the tangent at that particular point, and then we work out the gradient of that tangent, that's going to be our estimate for the gradient of the curve at that particular point. So let's draw the tangent at that point. Okay, so I've drawn my tangent to the curve at the point P, so that was the point P there, and we want to find the gradient of that tangent. So now let's choose 2 points on that tangent, 2 good points. I think that's a good point there, the point which has got coordinates negative 2.5, negative 3. And then if we go on up, let's have a look at another one. I think that's a good point as well, which is the point negative 1.5, and then in terms of the height, we've got here 1, 1.5, 1.7. Okay, so that's fantastic. We've got those 2 points. So now we want to find the gradient of the tangent, the line connecting them. So let's draw a little right angle triangle. And then we're going to work out our m. The gradient is the rise divided by the run. So in terms of the rise, we're going from a height of negative 3 up to 1.7. So that'll be a rise of 4.7. So 4.7. Divided by the run, which is we're going from negative 2.5 to negative 1.5, which would be 1. And 4.7 divided by 1 would be 4.7. So that's our estimate for the gradient. So let's write that down. So the estimate of the gradient of the graph at the point P would be 4.7. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on rates of change. And we've looked at instantaneous rates of change. So that's whenever we're finding the gradient at a particular point, we draw that tangent. But also we've looked at the average rate of change. So that's where we had 2 particular points on the graph and we joined them up with a chord and we found the gradient of that chord. And just to mention, obviously with these solutions, that our answers may differ slightly depending on how we draw those tangents. But obviously if you use the right technique, then hopefully you get the right answer. And that's it. And if you go on down, if you need any extra help on rates of change, if you scan the QR code or go to video number 390A or 390B on Corbettmaths, there's dedicated video tutorials there on rates of change. And that's it. So I really hope you found this video useful. And if you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers.